Madhu, so
Yes,
let's start your heat transfer snap for engineers in India Limited, EIL and BARC.
yes, sir.
Acha, Madhu, just tell me what is convection? What is convection heat transfer?
Sir, basically convection heat transfer is a mode of heat transfer through which heat transfer takes place from a hot solid to a fluid which is in motion.
Acha, what do you understand by advection and diffusion? You know,
Yes, sir.
like convection is a phenomena
Yes,
which
yes,
occurs by advection and diffusion.
yes, yes.
Mm-hmm.
Sir, convection is a phenomenon which is basically combination of both advection and conduction. Conduction takes place at the very vicinity, at the vicinity of the solid surface. There is a stagnant layer, which we through diffusion takes place, which we call it due to random molecular movement. And then coming to advection something like bulk fluid movement. Due to the bulk fluid movement, heat transfer takes place from the hot solid surface to the flowing fluid.
Acha, Madhu, like suppose if I will give you a case, there is a plate.
Yes, sir.
Okay.
Yes, sir.
There is a plate. One case the plate is like this,
Yes,
vertical,
sir.
and another case the plate is horizontal,
Yes, sir.
like this.
Yes, sir.
One case plate is vertical, another case plate
Yes,
is
sir.
horizontal. Okay. The both plates are of same size. दोनों प्लेट सेम साइज की है.
Yes,
Okay.
sir.
Same area,
Yes, sir.
same thickness everywhere, same
Yes,
temperature.
sir.
Okay.
Yes, sir.
So in which case the heat transfer will be more? Which is going to cool faster? Like if you are placing the plate vertically in a room or horizontally in a room, which one is going to cool faster?
Yes, sir.
And why?
So, mm, sir, in case of vertical flat plate, uh, mm, I mean, since it is a hot surface, let it the temperature be more than 100 degrees. And next, coming to the fluid, which is very near to the surface, air the temperature less than that. So, since gravity is also present, free convection takes place in vertical flat. I mean, at very near to the wall surface, due to density, the air comes lighter and convection current setup, and free convection takes place in the vertical wall. Since you said it is let us assume that there is no fan or not at all. And whereas in case of flat plate, there will be in case of horizontal flat plate, sir, in both the cases there will be free convection, right?
Yes, yes.
Free
Free
in both
convection.
the cases, free convection heat transfer takes place, but for in case of flat plate, H is able to get the point. I mean, I'm thinking that in both the cases, gravity is there, and same surface temperature, same medium. So I think heat transfer will be same in both the cases.
Both the
Here it is
both
even
are going
characteristic
to,
length is also.
both are going to cool at the same rate. Means same time. Both are going to take same time to cool.
Q is equal to yes, sir. Sir, in case of horizontal flat plate, H is equal to let us consider the laminar flow, free convection flat plate GR into PR. Sir, in case of flat plate, Nusselt number is some constant into GR into PR, right? whereas GR is equal to, the Grashof number is equal to G beta delta T into LC cube by V square. Denominator is constant, G beta delta is constant. Even characteristic length, you said vertical, both the dimensions, width and length is also constant. Even Prandtl number is also constant. I'm thinking that both the heat transfer, both cases heat transfer is same.
ठीक है. But how actually we check like which out of the free convection, forced convection, which one is dominating? How we check that?
So there is a dimensionless number known as Richardson number, where Richardson number is defined as the ratio of Reynolds number to Grashof number square. If Reynolds number is far greater than Grashof number square, then we can say that heat due to forced convection is more than heat transfer due to natural free convection. Then we can neglect the free convection. We can consider it as a case of forced convection. And converse is, if it is a Richardson number less than 1, we can consider free convection as a dominant one.
Okay. So if I will ask you, can you tell me the difference between local convection heat transfer coefficient and average convection heat transfer coefficient? What is the difference?
Sir.
What do you understand by local?
Basically, heat transfer coefficient.
Yes. Yes, please.
Sir, basically, heat transfer coefficient varies along. Let us consider an example of a flat plate, which is at more than 100 degrees Celsius. Generally, whenever a heat flows there, local heat transfer coefficient varies along the length of the flat plate. Since at a particular location, at a particular section, if you want the heat transfer coefficient Hx, then it is called local heat transfer coefficient. If we integrate over the entire length of the flat plate, then H is a function of x, right? So if we integrate the entire heat transfer coefficient along the length, then we can get the average heat transfer coefficient. Average heat transfer coefficient just tells about on an average, the convection heat transfer that is taking place from the flat plate to the surrounding air.
So in case of vertical plate, can you give me some kind of relationship between the average convection heat transfer coefficient and the local convection heat transfer coefficient? Madhu?
Yes, sir. Vertical flat plate. So it is free convection, right?
Yes. Free convection.
Yes. X is equal to.
Sir, free convection laminar flow. Okay, let us consider free convection laminar flow.
Free convection laminar flow. Nusselt number is equal to some constant. I don't know the constant, sir. GR into PR whole power N, where for laminar flow, N is equal to 1/4. And that too, it is for constant temperature heat plus boundary condition. And 1/3 for heat boundary. Laminar flow, constant temperature boundary condition, and equal to 1/3 laminar flow, constant condition, where GR is equal to G beta delta T into LC cube by U square, PR is equal to number mu C by T.
So what relationship you are getting?
Yes, sir. Give me a minute. Yes, sir. If gravity, all the parameters are constant, then Nusselt number is to the length power in case of laminar constant temperature boundary condition. And if you write Nusselt number is equal to HLC by K, and heat transfer coefficient is directly proportional to LC power 3/4 minus 1. Inversely H proportional to LC power minus 1 in case of constant temperature boundary condition for a laminar flow free convection. I mean,
Madhu, what do you understand
by
by
this we can say that
fine. What do you understand by emissivity? What is
emissivity.
emissivity? Yes.
Yes, sir. Sir, mm, emissivity. Yeah. Let us consider a body which is at a very high temperature. Mm, Basically, black body is a body which emits heat, which emits maximum amount of radiation heat transfer. But the bodies which are other than black bodies emit heat transfer very close to black body. Basically, what emissivity tells that how the body approximates as a black body, and mathematically it is the ratio of amount of radiation heat transfer emitted by a body per unit area per unit at a given ratio of the total radiation heat transfer emitted by a black body at a particular unit area.
How we can increase the emissivity of a particular surface, Madhu? On what factor emissivity depends?
Yes, sir. Emissivity, emissivity, absorptivity, reflectivity. Yes, sir. Sir, basically, we know the relation emissivity is sum of emissivity, absorptivity plus reflectivity is equal to 1. Let us consider solid which have approximately transmittivity 0. In that case, if we rough the surface, I mean, if we make the surface rough, sorry, you said the increase emissivity, right? Reflectivity increases. Yes, sir. Sir, if it is a polished surface, reflectivity is more, emissivity decreases. But if we make the surface rough, then reflectivity decreases, and obviously emissivity can be increased by making it rough.
By roughening a surface, we can improve the emissivity.
Yes, sir.
Okay. What is Kirchhoff's law of thermodynamics? Kirchhoff's law.
Kirchhoff's law
Yes.
of thermodynamics, sir.
No, not thermodynamics. What is Kirchhoff's law of thermal radiation?
Kirchhoff's law of thermal. Okay. Yes, sir. Let us consider a body which is in thermal equilibrium. I mean, let us consider some hot iron rod which is at more than 1000 degrees Celsius in a room. When thermal equilibrium attains, in that situation, Kirchhoff said that the emissivity is equal to the absorptivity of that particular body, which is in thermal equilibrium with the surroundings. This is Kirchhoff's law of radiation heat transfer.
So can you tell me the difference between radiosity, irradiation, and having spherical emissive power? What is the difference? And what is the relationship between them?
Yes, sir. Wait a minute, sir. So let us consider this is a surface. From a source, whatever the radiation falls on its surface, that is irradiation. While coming to radiosity, the summation of net heat radiating outside, the radiation includes both the radiation emitted by the body and also the fraction of radiated heat reflected. Both the things. I mean, emissivity into sigma T power 4 rho reflectivity into irradiation G. This is radiosity, sir. Whereas hemispherical emissivity is the total radiation heat transfer taking place per unit area in all the directions at a particular temperature.
Madhu, turn off your camera so that at least I will be able to listen to your sound clearly. Na? Turn off your video.
Yes, sir. Is it okay, sir?
Yes. Now it's fine.
Sir, whether my audio is not clear, sir?
Actually, I think there is some internet issue in between. Your voice is, not very much clear. Voice is interrupting actually. Okay, my last question is to you, Madhu. Madhu, what is NTU of a heat exchanger? What do you understand by NTU?
Yeah, sir. Sir, NTU means number of transfer units. And what I know, sir, I'm not that much. I'm not sure that I have just one thing, sir. NTU defines the size of the heat exchanger. More the number of transfer units, more is the size of the heat exchanger. Basically, NTU is equal to UA naught by C. Generally, we calculate in case of heat exchanger.
So what's the relationship between NTU and effectiveness?
Sir, it is different for different cases. In case of parallel flow heat exchanger, effectiveness is equal to 1 minus e power minus NTU into 1 plus R by 1 plus R.
Both are directly proportional or inversely proportional?
NTU effectiveness, sir.
Yes, NTU and effectiveness.
It is equal to 0, 1 plus C2 minus NTU into 1 plus R increases. 1 minus 1 e power NTU into increases, C2 increases. Sir, basically, if you take just take a I is equal to 0 for a balanced heat exchanger, then I
Although I'm not getting your voice.
Directly proportional, sir.
Directly proportional. Fine, fine. Okay, Madhu, let me give you the feedback now. So, Madhu, I asked you some question. Initially, I started with convection. What is convection? What is advection? What is diffusion? How the convection mode of heat transfer takes place. So, you answered those questions. Then I given you a case, like suppose we are having a case of vertical plate and horizontal plate, in which case, okay. Hello? Yes, Madhu, I think you lost your connection.
Yes, sir. Yes,
Madhu, just observe carefully. This is a case actually which I need to discuss with you. I have given you two cases. Like one case, the plate is vertical, another case, plate is horizontal. So as you know, the plate is a hotter one. The plate is hotter one. So the air, when it will come in contact with the plate, it is going to rise due to its density changes.
Yes, sir. Yes, sir.
So in case of vertical plate, the boundary layer formation will be very much smooth. Both surfaces, this side is this side.
Okay.
But in case of horizontal plate, the top surface boundary layer formation is fine, but in bottom surface you will have interrupted boundary layer formation. Why? Because air is coming in contact, but it will not be able to rise, na?
Yes, sir. Yes, sir.
So you will have interrupted boundary layer formation at the bottom surface.
Yes, sir. Yes, sir.
So overall, that value will be less and the heat transfer will be slower in case of that horizontal plate.
Horizontal flat plate,
so
yeah.
It is going to take much time as compared to the vertical plate, Madhu.
Yes, I got the point, sir.
Okay. So then I asked you about like in case of vertical plate, how you are going to develop that relationship between the average and local heat transfer coefficient. So you mentioned some relationship, but you know, due to some problem, I have not listened to you completely, but I think you proceeded in the right direction. You used some kind of relationship, then you use the relationship for the Nusselt number and the Gresham number.
And integrating over the flat.
Firstly, in Prandtl number is independent of the XL. Okay.
Yes, sir. Property.
But the Nusselt in Grashof number you will have L cube. Okay.
Yes,
so
sir.
actually you will get L ki power 3 by 4. Okay.
Yes, sir. Yes,
and
sir.
here in this side you are having
HL
by K.
HL in case of vertical plate.
So H you can write it as directly proportional to what? L ki power 3 by 4 minus 1. So
minus 1.
It will be what? L ki power minus 1 by 4.
Yes, sir. That's what I told, sir.
Yes. So isko further if you will solve this, you need to solve in that equation. If you will put H bar equal to integration 0 to L Hx dx.
Yes, sir. Yes, sir.
So अगर आप इसको solve करोगे, then you will get the relationship and try to get that relationship. I think you are going to get H bar equal to 4 by 3 HL.
Yes, sir. Yes, sir. Yes, sir.
Okay. So that relationship, I think you proceeded right. In that way,
yes, sir.
You are going to get the value.
I mean, I mean, I just explained orally, sir. I didn't
Ah, yes,
done
yes.
any in that calculation.
But you need to like if you are having some kind of camera, you can put it over your some kind of notebook, and then
Yes,
you
sir.
can show and you can demonstrate. Okay,
Okay,
sir,
sir. Okay, sir.
this is how we are going to get. Okay,
Okay, sir.
because
Okay,
hx
sir.
hx easily you will be able to write as c times l ki power minus 1 by 4.
Minus 1/4. Yes, sir.
उसको further solve करोगे, you will get the relationship.
Yes, yes, sir.
Uh, I think then I asked you about the emissivity. You answered emissivity. We can, yes, we can increase by roughening a particular surface. It's the ability how
Yes, sir.
much particular hemispherical emissive power of a particular surface in comparison to the black surface at
Yes,
any
sir.
particular temperature.
Yes, sir.
वो ठीक बताया आपने. Roughening करके या suppose some kind of selective coating also we can provide over a surface.
Yes, sir. Yes, sir.
Kirchhoff's law of thermal radiation, I asked that, you answered. Like a good absorber is also a good emitter of energy. Absorptivity is equal to reflectivity. Absorptivity equal to what?
Emissivity.
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 If a
Yes, sir.
particular surface is in thermal equilibrium with its environment.
Yes, sir.
Then I asked you about NTU and some relationship between G, hemispherical emissive power, and J. So all those questions also you answered. तो मेरे को ठीक लग रहा है अभी मधु. I asked you some basic question. I started with convection. I think you answered. Your approach is looking fine, but like when you are going for BARC, for EIL,
Yes,
it
sir.
will be fine.
Yes, sir.
They are going to ask you much direct questions, okay?
Yes, sir.
But for BARC, the interview will be slightly different. They are going to ask you some kind of linked question, okay?
Yes, sir.
They're going to start
Yes,
with some basic question, but then they will keep on adding the difficulty in that question.
yes, sir.
Madhu.
Yes, sir.
So in that case, it will be good if you are having some good internet connectivity, and next time if you will ensure ki yes, on some kind of paper pen you will have, and then if you will write and you will demonstrate in front of the interviewer ki sir, this is how I'm going to get this. So I think
Sir,
then that approach will be fine, good for BRC.
okay,
Okay.
sir. Sir, I have even I even have a pen and paper and writing something, but this is my first mock interview. I don't know whether I have to show individually or else a mentor will ask you show something. I'm
Yes.
waiting for that. I don't. This is my first mock interview.
Actually, why actually I'm not asked for that today, because even your video you made it visible, but I'm not getting I have not go to your video. Why?
Yes,
Because
sir,
only
that's
I'm
a big
getting
issue.
your the picture only, and that was static only due
Yes,
to
sir.
some kind of internet issue. Madhu. That's why I suggested you to turn off your video.
Sir, just a stagnant picture of me.
Yes, yes,
I'm
yes, yes.
explaining something with taking my
Most of the
pen
time.
and shaking my hands.
Yes, yes, yes. Most of the time, I observed only the static picture. Most of
Okay,
the
sorry,
time.
sir. Next time I will take care of that internet connection.
Okay, okay, Madhu.
Sir, one query.
Yes, yes, yes.
Sir, could you please tell me where I can improve my skills? I mean, whether any textbook for BARC, mainly for BARC. Just
BRC
suggest me something.
it will be good if you listen to some of the snaps. Actually, we started some kind of series also
Yes,
for
sir.
BRC. You can watch those kind of series.
Yes, sir.
Okay. Other than that, so many previous year interview experiences you will find on the
Yes, sir.
panel,
Yes, sir.
YourPedia panel. So just start
Yes,
watching those interview experiences, because
yes, sir.
finally you need to get some idea ki what kind of interview questions you are going to face, and you
Yes,
know
sir.
to develop some kind of understanding like how you need to approach like the
Yes, sir.
questions when interviewer is asking you. So how to tackle those kind of questions, Madhu.
Yes,
ठीक है.
sir.
तो थोड़ा सा आपको वो अप्रोच डेवलप हो जाएगी if you will appear in more and more snaps. So you need to make
Yes,
a
sir.
kind of target कि sir in next week I will appear for 2-3 snaps. Okay, I will prepare subject through some kind of initially marathon classes, then some kind of textbooks.
Yes,
So it is
yes,
good to
sir.
refer some kind of textbook also if you are having some
Yes,
standard
sir.
textbooks. So
Yes,
those
sir.
also you can refer for any particular 2-3 subjects. Okay,
Okay, sir.
totally you
Okay,
need to
sir.
prepare 4-5 subjects. Okay,
Yes, sir.
BRC.
Yes.
For ECIL, I think your knowledge is fine, and they are going to ask you direct questions. So if you are preparing for BRC, definitely
Yes,
you will
sir.
be able to get through that. Okay.
Yes, sir. Yes, sir.
Okay, Madhu.